Okay, here we are at the end of Chapter 5, Synthetic Division, and a rather important theorem called the remainder theorem. So, we have two objectives in this section. One is to use synthetic division. And the second is to use the remainder theorem. So as I said at the end of the last video, synthetic division is used when you are dividing certain polynomials. So polynomial long division handles everything. Monomials, binomials, trinomials, whatever you want to put on the bottom of that fraction, long division can handle. Synthetic division can only handle certain divisions. So synthetic division is an alternative way to divide polynomials by linear binomials. So that means things like ax plus b. Unfortunately, we cannot use synthetic division otherwise. And the reason for that connects back to the remainder theorem. So synthetic division is called synthetic mainly because it's not really division. What it is a way to check for zeros. And that's what the remainder theorem talks about. So we'll see what we mean by that in a second. But let's get some practice using synthetic division. So we're going to divide 2m cubed minus m squared minus 13m plus 1 by m minus 3 using synthetic division. So you're going to notice nothing that I'm about to write looks like division because it's not really division. So first is it's an upside down long division box. And whatever this value is here, we put the positive version here. If it's, or I should say we put the negative of what we see here. So if this was a plus, this would be a negative over here. And then you put your coefficients in order from greatest to least. So 2, -1, -13, and 1. And then I draw another extra line here. Some people don't. The first thing you do is bring the 2 down. You bring the leading coefficient down. Then we multiply 3 times 2, which is 6. Then we add. -1 plus 6 is 5. Then we multiply again. 3 times 5 is 15. Then we add. -13 plus 15 is 2. Then we multiply. 3 times 2 is 6. Then we add is 7. Now, we look at the highest degree that we had was 3. We divided by a single linear m, which means that this, I can write it down here, is going to be the m squared, the m, and then this is the constant, and this right here is the remainder. So our answer will be 2m squared plus 5m plus 2 plus 7 over, we divided by m minus 3 originally. And that would be our final answer. Now you can always check your work by multiplying this big thing by m minus 3 and making sure you get back to the original. And in fact, for the first couple, I would suggest that you do that just to see. I like this one. This one's not too bad. I would multiply all these terms by m minus 3, distribute that out, and see that it gets back to what we started with. And it will. Now, the second example is here, not just to see another example of synthetic division, but it also shows the trick with synthetic division that we have to be aware of. Or is that the next one? It might be the next one, yeah, because it's 4, 3, 2, 1. Yeah. Forget what I just said. But this is showcasing the negative. So we put our upside down division box. Since this is a plus, that means it's going to be a minus here. So when it's a minus 3, it's positive. When it's plus, it's negative. Bring our coefficients. This is 1, -2, -11, 5, and 34. I draw my little operation bar. Bring the 1 down. Negative 3 times 1 is negative 3. Negative 2 plus negative 3 is negative 5. Negative 3 times negative 5 is positive 15. Negative 11 plus 15 is positive 4. Negative 3 plus 4 is negative 12. 5 minus 12 is negative 7. And negative 3 times negative 7 is positive 21. 34 plus 21 is 55. So again, look at your top degree, and this is going to reduce it to x cubed, x squared, x, this is our constant, and this guy is our remainder. So that means our answer will be x cubed minus 5x squared plus 4x minus 7 plus 55 over, it was x plus 3 originally, as our divisor. So again, nothing about this looks like division. And it's not. That's why we call it synthetic division. It is synthetic. It is not a real division. It's not a natural division. What it does is make the remainder theorem possible. In fact, synthetic division was developed because of the remainder theorem. And they wanted a way to verify the remainder theorem quickly with any polynomial. And so I forget the mathematician who came up with it, what his name was, but they developed this quote-unquote division to make the check of the remainder theorem on any polynomial fast and efficient. So let's talk about the remainder theorem. It says if a polynomial p of x is divided by x minus c, so it's divided by a linear term, then the remainder is equal to p of c. In other words, whatever your remainder is what happens when you plug that number, c, into the polynomial. So, if we flip the page, we're going to verify that using this guy here. So this is why synthetic division exists, because if you had to divide this by long division, no one would ever want to do that. But with synthetic division, I can look at first what p of, in this case, 4 is. 4 times 4 to the 7th minus 25 times 4 to the 5th plus 35 times 4 to the 4th plus 17 times 4 squared. And I'm just going to punch that into my calculator, and when I do that I get 16. So I know what p of 4 is. The remainder theorem says if I divide it, I'm going to use synthetic division to check. So this is 4, negative 25, 35. Now this is where I thought we were doing this in the last example. This is where synthetic division really rears its ugly head that it's not a true division. So with long division, we don't care what's missing. Right? We divided a couple that didn't have every single power. Synthetic division, since there's only a fourth power and a second power, says we need to account for that third power that's not there. Because we could always add, right here, say plus 0 x cubed. 0 times anything is 0, so no matter what x is, this is still 0. So that's our cubic coefficient, our quadratic coefficient, and then also we need a plus 0x and a plus 0, so we need a 0 and a 0. So this is what I meant by synthetic division really isn't a division, because it requires you to have every coefficient even when they don't actually exist. Even when your polynomial is missing those terms. If you don't have a cubic term, you put a 0 in between the fourth and second power. If you don't have a linear term, you put a 0 between the second and first. If all you have is a sixth power, the rest of these all would have to be zeros. So again, I can't stress this enough. Synthetic division isn't really division. It was developed to be able to check with the remainder theorem quickly whether or not it was true, and then also give you a way to calculate it without having to do this. Because remember, way back in the day, no calculators. So you're either doing this on an abacus or by hand, and man, is that not fun. 4 to the 7th. Lots of tedious multiplications. So let's check this out. Bring our 4 down. 4 times 4 is 16. Negative 25 plus 16 is 9. 4 times 9 is 36. Negative 9, sorry. 4 times negative 9 is negative 36. 35 minus 36 is negative 1. 4 times negative 1 is negative 4. 0 plus negative 4 is negative 4. 4 times negative 4 is negative 16. 17 minus 16 is 1. 4 times 1 is 4. 0 plus 4 is 4. 4 times 4 is 16. 0 plus 16, 16. Well, that's our remainder, and that's what we got. So that's the purpose of this. Now, I will say the remainder theorem is really important because when you do these checks, if you go on to Math 96 or Math 104, using a synthetic division check on a linear term will tell you whether that factor goes into it evenly, whether you can actually factor it using that term. So this is a really common practice when you're trying to factor really big polynomials. We do it a lot in college algebra and pre-calculus. So our remainder theorem checks out. So now when it says find P of 3 using the remainder theorem and synthetic division, it means I don't have to plug 3 into this anymore. Which of course if you have a calculator isn't terrible, but it also just allows us to do 3 into the coefficients, negative 18. And again, we're jumping from 4 to 2, so I need a 0. 90, 59, and then I don't have a constant, so I need a 0. Bring my 2 down. 2 times 3 is 6. Negative 18 plus 6 is negative 12. This is negative 36. Plus 0 is still negative 36. 3 times negative 36 is negative 108. 90 minus 108 is negative 18. Negative 18 times 3 is negative 54. 59 minus 54 is 5. And 3 times 5 is 15. Plus 0 is still 15. So that means that P of 3 equals 15. And indeed, if you check that in your calculator, you will see that it does equal 15. And again, I know a lot of you are looking at this going, well, I have a calculator. What's the point of learning this? One, it's a little bit faster than doing it by hand. Obviously, calculators make a lot of things irrelevant to do by hand. And that's just the nature of advancing in technology. But if you do go on to a 96 or a 104 or a 141, you're going to be using synthetic division to factor really big polynomials. Because in those classes, we say, okay, factor this cubic or factor this 6th degree polynomial. And you're going to have to just guess at terms. And synthetic division is a fast, efficient way to see if you're right or wrong on those factorizations. Now for our class, you don't need to worry about that. Just wanted to give you some idea of why this is useful, because I usually get a lot of pushback in this class about what's the point of synthetic division if we have calculators. And the answer is it's a setup tool, and it's also a neat little trick. Because this, as its name suggests, is completely man-made, whereas polynomial long division comes from the rules of mathematics, the rules of nature. Okay, that's the end of Chapter 5.